Right now, enterprise AI adoption is fragmented. Individual teams are running isolated experiments, bolting language models onto existing workflows, and allowing shadow IT to expand across the organization without central oversight. This ad hoc deployment creates immediate structural liabilities. When AI tools are integrated without a uniform architecture, they generate irreconcilable data silos and operate entirely outside of corporate governance structures. To extract actual, measurable value and mitigate these liabilities, organizations have to stop treating AI as a series of disparate software installations. It must be integrated as a formalized architectural standard. That architecture is defined here: the Project Management Institute's Standard for Artificial Intelligence in Portfolio, Program, and Project Management. The standard provides a framework designed specifically for leaders executing strategic vision across portfolios, complex programs, and projects. This document outlines a complete methodology. The numbered list details the components required to build a functioning AI ecosystem. To understand how this works, we will translate the document's three main structural components: the guiding principles, performance domains, and lifecycle tailoring. Treating an AI model like a plug-and-play tool is a failure of execution. It is an enterprise capability, and it requires careful construction. A robust AI system starts with logic, not technology. The framework rests on a base layer of 8 foundational principles. The first 2 dictate intent. Strategic value ensures AI aligns with business objectives. Governance and compliance establishes mechanisms guiding responsible use. The third principle, risk, requires a conceptual shift. Managing risk in an AI environment means dealing with dynamic, learning algorithms that can introduce novel threats to an entire portfolio's safety and security. To counter this, the standard mandates a strict human-in-the-loop architecture. AI models are excellent at generating predictive insights, but they cannot autonomously execute project variables. A human leader must remain at the decision gate before a prediction converts into a deterministic action on the budget or schedule. This leads directly to the requirement of data quality. Machine learning is entirely dependent on historical accuracy. If your organization's past project data is disorganized, mislabeled, or incomplete, feeding it into an AI will simply mechanize and accelerate those flaws, compromising future predictive insights. The final 4 principles complete the base: ethics and professional responsibility, and stakeholder engagement, a focus on people and culture, and continuous improvement. These 8 blocks provide the necessary constraints. Without this base, a model lacks the governance and data integrity required to prevent the automated scaling of existing project errors. With the philosophy set, the framework moves to the execution layer, the 5 performance domains. This is where principles become daily operations. Domain 1 is scoping AI. Project managers must define the specific boundaries of the tool to ensure it adds measurable value to the stakeholders of a given portfolio. Domain 2, designing AI architecture with quality and reliability, focuses on the technical build. It demands rigorous system design to maintain enterprise-grade security and data privacy. Domain 3 is executing strategic AI objectives. Project leaders must coordinate their machine learning initiatives directly with overarching business goals, allocating resources based on the actual impact. Domain 4 covers managing AI risks and uncertainties. This operationalizes our earlier risk principle, requiring continuous threat monitoring specifically tailored to the unique vulnerabilities of AI tools. Finally, Domain 5 focuses on managing AI stakeholder expectations. Project managers have to cut through vendor hype and align the team's understanding of what the AI can actually deliver, keeping expectations grounded in reality. These 5 domains act as the load-bearing pillars, converting high-level mandates into manageable, step-by-step project workflows. The capstone of the framework addresses the point of highest operational friction: lifecycle tailoring. Standard project delivery lifecycles, whether predictive or agile, follow specific cadences. The lifecycle of developing and deploying an AI model is entirely separate and highly nonlinear. Look at how they overlap. The standard details the specific phases of the AI lifecycle: data preparation, model development, deployment, and monitoring. The project manager's job is to pinpoint intersections on this matrix. For example, AI data preparation must be perfectly synchronized with the standard planning phase of the core project. Mismatched timelines here are disastrous. If the data science team and the project delivery team operate on asynchronous schedules, they will completely block each other's progress. This tailoring process is universally applicable. It provides the integration engine regardless of whether the office runs on rigid predictive structures or highly adaptive hybrid methodologies. The ultimate success of enterprise AI rests precisely here, meticulously synchronizing the machine's learning curve with the actual delivery timeline of the project. Zooming out, this structural model has to operate within the real-world pressures of a large organization. This brings us to Section 7 of the standard, the unavoidable legal and ethical considerations that act as strict compliance gates for the entire framework. Managing portfolios with AI introduces specific legal exposures. Organizations must navigate intellectual property rights, data sovereignty, and maintain algorithmic transparency to satisfy discovery and audit requirements. On the ethical side, the standard recommends establishing dedicated oversight committees. These groups are responsible for testing the AI's outputs to ensure they remain fair, inclusive, and free from systemic bias. The framework places human accountability at the center of the process, ensuring that final liability for outcomes rests with project leadership, not the algorithm. By automating the monitoring of high-volume data points, the system provides real-time portfolio optimizations, allowing human directors to focus their attention on complex strategic trade-offs. Success relies on executing the complete triad: ethical principles at the base, actionable domains as the structure, and tailored life cycles to synchronize the workflow. The PMI standard elevates AI from a chaotic experiment into a rigorous, governable asset. This is how the future of project management is architected.